Good morning, dear students. Welcome to this session on pre-stress concrete, Unit 2. Uh, Last session, we have talked about this pressure line concept, and also we have been elaborately discussed about this difference between RCC and pre-stress concrete behavior when resisting the external moment. Uh, these are the formulas that are to be used if you want to evaluate these stress at top, stress at bottom using this pressure line concept. Okay, so E dash is defined as the distance between the CG of the cross section of PSC beam and the CG of the compression. Say for example, if this is the CG of the compression and this is the CG of cross section, so this distance we refer as E dash value. Whereas E is different, that is the distance between the tendon and the CG of the cross section is called eccentricity of the tendon. Okay, so this is E value. So that's a clear difference between E and E dash. Right, so to get E dash value you need a small a value which is called lever arm. Lever arm is nothing but the distance between the tendon and the compression, the center of compression. So this is called lever arm small a, which is obtained by bending moment divided by the pre-stressing force. Okay, this is what is small a value. Right, so this is how this is replaced, and E is the eccentricity of the tendon. So with that information you can get this E dash value. So using E dash, because it is acting, the center of the compression is above this CG line of the cross section, so we will have top compression, bottom tension. So bending stresses top compression, that's why it is plus, and bottom tension, hence it is minus. Okay, we will see an example here. So a pre-stressed concrete beam with a rectangular section of 120 mm wide by 300 mm deep. So let us draw the section. Is 120 mm wide, 300 mm deep. This is the cross section. Supports a uniformly distributed load of 4 kilonewton per meter, which is nothing but the load value, which includes self weight of the beam, which means the total load value W. It is like G plus Q, both the values. Okay, so that is this one. So live load plus dead load is 4. The effective span of the beam is 6 meters. 6 meters is the span of the beam. The beam is concentrically pre-stressed by a cable uh, carrying a force of 180 kilonewton. Locate the position of the pressure line in the beam. Okay, so pre-stressing tendon is at center, concentrical. It is told that it is concentric. So which means it is 150 from top or 150 from bottom. Okay, right. By pre-stressing force P value of 180 kilonewton, locate the position of the pressure line in the beam. This is the question. So how to locate the pressure line of the beam? Okay, right. So let us calculate M by P values. They will give you lever arm values, which are called something like A values. Okay, right. Whereas here eccentricity is 0, where E is equal to 0. Okay, because it is concentric tendon, so A is equal to actually E plus E dash, right? From the earlier discussion, it is like E plus E dash, where E is equal to 0 now. So whatever A value you get, like M by P, it is equal to E dash, nothing but what is E dash? Distance of center of compression from CG line. So this is something like directly you are getting E dash value by calculating A itself, right? This is what we are going to do. Okay. So these are like E dash values, which are nothing but A values only. Leave on. So P is directly available. Just get M value. At center, it is WL square by 8. So W is 4, L is 6. It comes out to be 18 kilonewton meter. So that is like 18 10 power 6 Newton mm. Okay. And uh, P is 180 kilonewtons. Convert to newtons. So finally you get 100 mm is the distance of center of compression from CG of the cross section at center. Okay, this is the location of compression line at center. Similarly, we work out for the other locations, like some other location, like maybe 1/4 of the span, so that you can easily draw this because of symmetry. So I am working out the location of compression line at center and also at 1/4 distance, so that the other half of the beam also you can produce it in the symmetric manner. Okay, right, like get it for MD. D is nothing but there is a point I take at L by 4 distance, is a D, is L by 4 distance I take. So bending moment at this point, it is like WL by 2 is the reaction. Okay, this is the reaction RA, let us say, into distance L by 4 is bending moment from reaction. This is clockwise and this is like minus anti-clockwise, minus W into this distance L by 4 into the center of this span L by 4 by 2. That is what is bending moment at 1/4 span. Just substitute the values. 4, L is 6, and L by 4, 6 by 4, W is 4 again, L by 4, 6 by 4, L by 4 by 2. That's coming around 13.5. This is like D, not C. E dash, where it is something like A only. So 13.5 is the bending moment. You can see center bending moment is 18, whereas at 1/4 it is 13.5 divided by P only, M by P only. So it is like 75 mm. That comes to 75 mm. So this is how we calculate A values. Okay, at center and 1/4 distance. The same values are holds good for the other half also. Okay, what about the support? Okay, where what is the bending moment value at support? M is equal to 0. So A is equal to M by P, which is equal to 0. M is 0, A is also 0, which means at support section, the compression line is at the center of the section itself at support. So this is a point where center of compression lies, and at 1/4 distance, it is at 75 mm above this line, and at center of the section, center of the beam, that means middle of the 6 meters, 100 mm. So now you can draw that diagram. So this is the location of compression line at support 0, and this is at center 100 mm, and 1/4 distance, this is 75 mm. And same here, 1/4 distance, it is 75 mm. It is symmetry. That is what is called pressure line. Okay. So these are all, in short, the solutions that we have worked out are being kept here. D is the location where we have taken 1/4. C, it is 100. So this problem is just to draw pressure line. If you want to answer any other question like what are the stresses at top and bottom, using this E dash values, you can also produce the stress diagram also, resultant stress diagram also, by the formulas that we have derived like this. Top stress, stress at bottom. With these formulas, you can easily work out. So you have cross section, you have pre-stressing force, you have E dash values. Okay, you have Z value. You have cross section, you have Z value. So you can easily work out all these stress at top and bottom at any cross section, maybe at center or at support or at 1/4 section, anywhere it is asked. Okay. So this is how you can solve the problem even with the concept of pressure line, not only by the superposing the stresses from pre-stressing, stresses from dead load, live load. That is one way of solving. The other way, if you are asked for pressure line concept, draw a pressure line and find the stress at top and bottom of the cross section using the pressure line concept. Likewise, if you are asked, you have to follow this procedure. Okay. So to locate pressure line, it is very simple. Always try to work out M by P value, bending moment at a cross section that you have taken, maybe at center or maybe at 1/4 distance. Likewise, okay, P is a given force, pre-stressing force. This will give you small a value, nothing but lever arm values. Okay, so that will locate the CG of compression, that is pressure line, from tendon line. In this case, the problem, the tendon is at center, hence E is 0, eccentricity is not there. So E dash itself is a value. That is a uh, the simplicity in this problem, right? So this is how you can solve a problem using this concept, and must draw the pressure line like this. Okay, why parabola? Reason, you can simply see P is constant, E is directly depending on bending moment. So bending moment for a simply supported beam with UDL is parabolic. So this is directly proportional to this. So this also shall follow parabolic nature. That's why the parabola is drawn here. Okay, and at support it is 0 at A. So for example, E dash A is equal to 0. That is equal to E dash B value at A and B also. I mean this is A. So support B, center C, 1/4 point D. Okay. So this is how you completely analyze a problem using pressure line concept. Okay, right? We'll see a lot more examples, and also I suggest you to take up the example problems, try to solve them, practice, and understand clearly what exactly is being done in the prescribed textbook. Right? Thank you.